one is part 171. It's line 18A, a3z5a2, Janet Conrad Mini-BooNE Fermilab Neutrinos Baby Oil Wow Seti. And there's the radial signal. Here's the Mini-BooNE experiment. I got a picture of it. I'll read you what it says. The charged particles are bent in the direction of the detector by the magnetic field. It's there. About half of the particles decay to produce neutrinos in a 150-foot pipe. Everything but neutrinos is absorbed at the end of the beamline. The neutrinos fly through about 3/10 of a mile of dirt unimpeded and maybe then oscillate. Physicists look for telltale light rings from electrons in a tank 40 foot in diameter filled with mineral oil and phototubes. That's what it looks like. That's their basic diagram of what it looks like. So that's from Janet Conrad in the Mini-BooNE detector at Hahn. And it's www.nevis.columbia.edu. March 17, 2012, my thoughts. I started to read this article because I wanted to know if anyone's coded neutrinos before, trying to oscillate them so that they will sparkle for the phototubes. I pulled out various paragraphs that talk about how they oscillate neutrinos. Now this information is from 2004, so I'm not sure if they do it the same way or if they've updated this experiment to include other things. What I like about David Appel's article in the University of Columbia's magazine about a Fermilab CERN scientist, Janet Conrad, and a colleague, Mike Shevitz, along with a team of 9 other people, is that it's explained in simple English so that I can understand it better and so can you. That's why I went through all the details of how they do the experiments. If we're going to put our heads together and create a new formula for them to try, you need to have a basic idea of what needs to be done. I've read other articles and used all the scientific terminology, and I really didn't understand the whole concept. This has enlightened me. I'm glad it came up during my WOW alien radio signal research. I'll have to look and see if they've posted the results of that data, and if not, could someone please write an article up about their findings and let me know where I can read it? Thanks. The keywords that we want to work on from David's article are wave interference, interference effect, muon neutrinos, and carbon atoms. A few of these muon neutrinos are expected to have oscillated before this collision. On March 17, 2012, so from what I gather from David's article is this: they want to convert a muon neutrino to an electron neutrino so that it will collide and split to generate energy or force. So this is Janet Conrad. She studies the nature of neutrino in an article by David Appel from Columbia Magazine 2004. And she's showing a Mini-BooNE detector, like a mini version of it. Okay? That's from Nevis, Columbia. And this is what it really looks like. So this is the experiment inside the Mini-BooNE detector, a 40-foot sphere lined with 1,280 phototubes now filled with mineral oil. So I googled quote neutrinos before collision. March 17, 2012. My thoughts. I've taken keywords from the data. This article about neutrinos explains this scientific experiment in detail. I assume it was written in 2002 because it talks about them taking 2 years to pull data in 2004. I've taken some of David's paragraphs and paraphrased some, while others are direct quotes from his article. Quotes to read. Source: Columbia Magazine, University of Columbia, from David Appel. Janet Conrad, a Columbia physicist, is working to unravel the secrets of a world that is all around us yet completely transparent. An intricate part of the universe, but one just beyond the frontier of human knowledge. Conrad's target is the neutrino, a wispy subatomic particle, whose true nature has eluded physicists for decades. By way of Euclidation, Conrad and her colleagues have built an instrument that hopes to capture some of the intricacies of the neutrino to catch it changing partners in its elementary dance through the universe. By observing oscillations of the neutrino, spying it as it exchanges costumes from one character into another, Conrad and her experimental collaboration hope to help settle basic questions about the neutrino and its places in the cosmic fandango. Quote, its shyness earned the neutrino its name. The Italian physicist Enrico Fermi called it the little neutral one. Random quotes from the article. Hypothesized to exist in order to explain the apparent disappearance of energy in certain subatomic reactions, neutrinos were positively identified in a 1956 experiment. But that discovery was only the beginning. Soon it was found that neutrinos come in two different flavors, the electron neutrino and the muon neutrino, distinguished by the nuclear reactions that give rise to their creation. 2 years ago, a third type of neutrino was found, long expected, the tau neutrino. A 1995 Los Alamos experiment stunned the physics community when it reported a few incidents in which a neutrino of one flavor transformed itself into a neutrino of another. The Mini-BooNE is a large detector set up to detect neutrino oscillations, specifically a change of the muon neutrino into electron neutrino. Set at the Fermilab National Accelerator Laboratory in Illinois, it consists of a 40-foot sphere filled with 800 tons, or 250,000 gallons or 30 tanker trucks of mineral oil. That's a lot of oil. Basically, says Conrad, it's baby oil. The Mini-BooNE experiments with neutrinos. Quote, Mini-BooNE will look for a characteristic pattern of light inside the tank. A beam of muon neutrinos produced by interactions of protons from Fermilab's booster ring will enter the tank. A few of the muon neutrinos will collide with the carbon atoms in the mineral oil and produce a highly energetic particle called a muon, which is essentially a heavy electron. The muon will produce light, called Cherenkov light, as it shoots through the mineral oil and out of the Mini-BooNE tank. Quote, if the prior Los Alamos experiment is correct, about 1,000 electron neutrinos will collide with the carbon atoms, produce a different Cherenkov light pattern that will serve as Mini-BooNE's important distinguishing signal. The Cherenkov is the key. Cherenkov light is a shock wave phenomena produced by any particle that travels through a medium, mineral oil in this case, at speed faster than light would travel through the medium, the electromagnetic equivalent of a sonic boom. This does not violate Einstein's dictum that nothing can travel faster than the speed of light, which is true only in a vacuum. In the Mini-BooNE's tank, any entering muon neutrino from Fermilab's muon neutrino beam will collide with the carbon atom and produce a highly energetic muon. This muon will hurry through the mineral oil, producing a cone of Cherenkov light that in turn will travel to the edges of the tank. There, an array of photomultiplier tubes, essentially inverse light tubes, will receive the light and produce an electrical signal. Quote, should any muon neutrinos in the muon neutrino beam have oscillated to electron neutrinos before entering the tank, they will, once inside the tank, collide with carbon atoms and produce instead of muons electrons. These electrons will scatter and bounce around because they are so much lighter than the escaping muons and will quickly come to a halt as they collide with mineral oil atoms. This produces a Cherenkov cone with fuzzy inner and outer edges, smeared by the bouncing around. After 2 years of taking data, the group hopes to have results by summer 2004. I still haven't found those results though. Quote, if neutrinos do indeed oscillate, basic principles of quantum physics imply that they also have mass. Quote, in fact, Mini-BooNE might see such sterile neutrinos if their initial muon neutrinos simply disappear, having oscillated to the fourth flavor. Now remember they said fourth flavor there, okay? So this was written by David Appel, okay? And you can see the article at www.nevis.columbia.edu. Okay, March 17, 2012, my thoughts continued. Again, this brings up my idea that the neutrinos split into 4 quarks. They call the fourth a sterile neutrino. Quote, a fourth neutrino might confound experimental physicists, but it could be good news for theoretical physicists. A fourth flavor of neutrino, Conrad notes, routinely falls out of the historic theories that tried to unify the 3 microscopic forces: the nuclear force, the electromagnetic force, and the weak force responsible for radioactive decay with the macroscopic force of gravity. And that's the Nevis Columbia EDU site. So March 17, 2012, my thoughts. To quote about the sterile neutrinos, several things stand out here. Keywords: the nuclear force, electromagnetic force, weak force, radioactive decay, macroscopic force of gravity, and all create neutrino oscillations. Again, there's the videos, there's 5 of them together. So you want to start at this one, line 18, a3z5a, for this section here. Each section has a little series of videos that go together, and I'll let you know if what happens is I take this one here, and I divide it because there's so much data, so it divided into 5 instead of 1. And there's the tags, which you'll see on the video itself. Okay, so we're going to go on to the next one, part 3.